Alright, so you may recall that previously we've made functions that can take other functions as arguments. That's actually just what we've been doing, but now we're going to do it a bit further and take functions that return functions as arguments. So let's say we've got this is sort of a trite and simple example, but let's say we've got a we want a bunch of adders. That's adder like this. Okay, and we want to do things like we want to be able to type adder 7 and have that always add 7 to something like 3. So it will do adder 7 and it should return 10. But of course we don't define it yet. But let's say we've got to make a bunch of these things like adder 7 and adder 9. And this is of course a trite example because you would normally just do like plus 7 and 3 or something. Alright, that's trite. Oh, but it's not actually well, yeah, it is sort of trite if you know what that means. Alright, then but let's say for some reason we want this. We want to be able to define a function that just takes one argument and adds 7 to it, so 9 or 20 or 374, something like that. So let's make a function called makeAdder that will return a function that adds 7 or whatever number. So let's look here. So a function that would return 7 to that would add 7 to an argument would be like this: lambda x plus 7x, and of course we can run that function on this like 3. Alright, and get 10. So we could just go define adder 7 lambda x plus 7x, and then we can do adder 7 3 and we get 10. We can adder 7 7 and we get 14. Alright, but we don't want to have to type this out every time. We don't have to. But if we do adder 9, we don't want to have to go through. Let's do it again though, just to show you how much trouble it is. Adder 9 lambda x plus 9x, like that. Then we got added 9 there, but let's say we want added 12 now. It's just a lot of work doing all this, isn't it? Alright, so add a 12x. Alright, then okay, let me show you that they work though. Add a 9, 3 is 12, add a 12, 12 is 24. Alright, so what's common about this? About these adders, we've got this lambda x, and then we just add either 7, 9, or 12 to x. So we add whatever number, let's just say n, we add n to x. So let's make a function called makeAdder that takes n and returns n being either like 7 or 9 or 12 or whatever number we want to make the adder, and it will add it to x. It will not add it to x. It will return this function, this lambda function, which adds n to x. Alright, so makeAdder is a function in and itself that takes n being this like 7 or 9 or 12, and then we return the function lambda x plus n and x. Alright, now this is about as simple of an example as I could come up with that was still halfway functional, so I hope you can understand it. So define now we can define adder 7 to be the makeAdder makeAdder 7, and then whenever we type in adder 7 we get the function lambda lambda x plus nx plus 7x. So we can do 5. There we get 12, that's right. Then we can define adder 12, make adder 13, whatever. Oops, no, we're supposed to make it 12. Alright. So, now that's pretty useless. I'll admit that it's sort of a useless thing, this make adder thing. But here's another example of something that's not so useless, and that is the composition of functions in mathematics. Suppose we've got two functions, f of x equals x plus 1, and f of y, g of y equals y times 5. Alright, let's say we want to compose these functions. So the composition of these two functions, of the composition of f and g, equals some new function, we'll just call it h, of, no, never mind, forget that I said h, equals f of g of x. So it equals g of x. First we do g of x. Well, this is technically like that. So the composition takes one argument, it returns g of x, and then returns f of x of that. So it's alright if you don't understand that. So it's like basically equals f of, what is g of x? G of x is y times 5. Oh, x times 5. Oops, I hit the mouse pad when I wrote that. Alright. F of x times 5, because g of x is y times 5. Well, g of y is y times 5, so g of x is x times 5. So if we do f of g of x, then, well, yeah, so then we get x, f of x times 5, which equals, let's see, x times 5 plus 1. Alright, so we didn't want to have to go, we want to make a scheme function now that will automatically compose two functions that just take a single argument together. So we want it to return a function that is f of g, and it takes two functions, f of g. So let's define compose lambda, and we take two functions as arguments, f and g. Alright, then we want to return a function which takes yes, what does this function take as an argument? It takes just x, because we're just composing functions that take single arguments. Both f takes a single argument and y, and g takes a single argument. So we want to return a function that also takes a single argument, because we can't do anything with any more arguments, because our functions can't do anything with more than one. Alright, so lambda x, f of g of x, and that's the composition there. Alright, so let's get rid of that. Alright, so suppose we want to compose the well, first let's define add1. Define add1 lambda a. If only we had make adder, we could do this a little faster, but I got rid of it. Oh, darn it. Plus 1a. Alright, so let's do compose add1 and square root, and what will that do? So this just returns a function, a procedure. So when we hit this, it's just going to say procedure. There, we just did a procedure. Alright, but let's say we want to actually run this procedure. Then, like other procedures, we have to put it at the beginning of a parenthesis. And then for the arguments, let's run it on, well, let's do something that we can take the square root of, like 9. So first it's going to run it into square root, to be square root of 9, and then it'll be the add 1 of that. So it should be square root of 9 is 3, and then add 1 to that is 4. So it's like we expected. Now let's compose, let's define add 2, just using compose. What do we have to compose to add 2? We have to compose, well, add 1 and add 2. I mean add 1 and add 1. Add 1, add 1. So now we can do add 2, 4, we should get 6. Now let's say we want to do add